Hey everyone, this is Alicia, and this is me and my partner Cameron CS61B Project 0 and Body Simulator. In addition to implementing the original simulation of the movement of planets in a universe, we have set out to implement a simulation of inelastic collisions among planets in a single spaceship, which will be treated as another planet. So here, let's start off with our demo. We will have user input the duration of simulation, the time change, and also the universe file, and indicate whether they would prefer a spaceship, and if yes, we can use the keyboard's WASD to control movements of the spaceship. Let's try no first. So as you can see, the planets collide with each other, and since it is an elastic collision, they stick to each other instead of bouncing off and exploding, and they get drawn to the sun. That's without a spaceship, so let's add a spaceship, which is basically a planet that the user can control, and things are about to get interesting. So this run, we'll just not use the WASD buttons to control the movement of the spaceship and see what happens on their own. The spaceship also bounced off a few times before getting stuck to the sun, and right after a planet, of course, hit both the sun and the spaceship. So the Earth gets stuck to the sun and everything else bounces off. And now let's try that again as I, the user, control the spaceship. Looks like my controls are not that significant since the gravity of the sun is drawing in the spaceship. And let's see if I can just hit some planets here. No? Well, there we go. Ooh. Ooh. So let's try one where I press the spacebar and the plane instantly loses velocity, and off we go. So in an inelastic collision, the objects that collide stick together, resulting in kinetic energy being lost by bonding the two bodies together. So that's why we sometimes don't observe planets bouncing off of each other. Let's look at the changes that were made to body.java in Body Extreme. One of the main methods that we updated was update, originally taking in 3 parameters. We also added an additional parameter, which is an array of Body Extreme. Update divides the code into 2 cases. We also wrote an additional method collides with to see if this body collides with any body in an array of bodies. So how do you know if 2 bodies collide? This is how we determine it. Let's draw a diagram here. The distance here is the distance between the centers of body 1 and body 2. And if that distance is less than the sum of R1 in blue and R2 in red, then that indicates that there is a collision that occurs between the 2 bodies. So if there are no collision, which means the collides with method returns an empty array, then we use original equations that we wrote in body.java to update the velocity of this body. However, if there is collision, we call both new methods to calculate new net velocity of planets in both x and y directions. But either case, we have to update the position of this body. It's just the velocity that is different. A closer look into the collision velocity x and y methods. Many equations to calculate the change in velocity for object collision in 2D without knowing the final velocity. So these are the 2 main equations. The top one is in x direction and the bottom one is the change in velocity in the y direction. And these equations are special because we do not know the final velocity. Of course, we have to calculate the collision angle. We call a different method, and it's denoted as phi here in the equation. How we do that is we use arctan. Other methods that we had to write in order for collision velocity x and y to work are calc direction, calc val, and collides with, which takes in an array of body extremes. We also had to make alterations in nBodyExtreme.java. So most changes are in the method read bodies, since that's the method that parse through the planets that are available to us in this universe. Since we created an additional instance attribute radius in body extreme, we have to read in an additional double for every body in the file. After you read all planets, If the user wants a spaceship, then we must expand the length of the array and create a new body representing the spaceship. As I mentioned in the beginning, we treat the spaceship as another body. The difference is that the spaceship is driven by the user. As I've demonstrated through the demo, the user interaction part with the keyboard control still needs improvement. One of the problems that we've noticed is that the new velocity that we have calculated after a collision between bodies is that this new velocity is often inadequate to overcome the force of gravity that holds the planets together. As you remember, there were many bodies, including the spaceship, that consistently got stuck to the sun. And we have still yet to figure out a solution, and we are still trying to improve that part. One of the solutions that we came up with is decreasing the mass of bodies, but we have yet to experiment with that. If you have any suggestions, please leave a comment down below. And thank you for watching our n-body simulation, and we hope you enjoyed it.